So let's look at the next question, question number 3. It says side AC of a triangle ABC is produced to E so that CE is equal to half AC. No diagram given, so let's just try and draw a rough diagram on our own. So let's look at this. It says AC is produced. So let me try and produce AC further in a manner that CE is equal to half of AC. Perfect. So then I have this as C and this as E. Next, D is the midpoint of BC. So let D be the midpoint of BC. This and this are equal. It's given. And ED produced meets AB at F. Okay, so ED is produced and it meets AB at F. Perfect. So this is point F. Next, lines through D and C are drawn parallel to AB. So a line is drawn parallel from D to AB, something like this, which meets AC at P. So this is parallel to AB. Wonderful. And again, a line is drawn parallel from C, which meets EF at R. Okay, so this is also parallel and it meets EF at point R. Perfect. Let's read the question. Side AC is produced. CE is equal to half of AC. Done. D is midpoint of BC. Done. ED produced meets AB at F. ED produced meets AB at F. Lines through D and C are drawn parallel to AB. Drawn meets at P and meets at point R. Perfect. So what do we have to prove? We need to prove that 3DF is equal to EF. Also 3 times DF is equal to EF. So basically we'll have to prove that FD, DR and ER are equal. If we can prove these are equal, then we will have our answer. Perfect. So let's see how we can apply either midpoint theorem or equal intercept theorem to solve this question. So let's look at the first part. So let's start with looking at a triangle ABC where I can find a midpoint and I can find a parallel line. Perfect. So then I will start with midpoint theorem. So in triangle ABC, let's see what I have. Number 1 is D is midpoint of BC. This is given, and DP is parallel to AB. Both of these are given. So using midpoint, no, not midpoint, this would be converse of midpoint, right? So using converse midpoint theorem, I get two things. Number 3, which is AP is equal to PC. What I get is P is midpoint, which means AP and PC are equal. And number 4, I get is DP is equal to half of AB. Perfect. So these are the two things that I get. DP is half of AB and AP is equal to PC. Perfect. Let's see if something else is already given to us. What is given is CE is equal to half of AC, right? And from 3 and 5, what do I get? AP is equal to PC, which is equal to half of AC. Let's write this as well to make it clear. AP and PC are equal and they are half of AC. So from 3 and 5, I get number 6, which is CE is equal to AP is equal to PC. Right, all of them are half of AC. So if I have put 2 lines here, which means CE, AP and PC are equal. Perfect. Now I can apply equal intercept theorem because I have a transversal, I have a pair of 3 parallel, not a pair, a group of 3 parallel lines, and EA and EF are transversals. If it is making equal intercept here, it will make this equal intercept on the other side as well. Perfect. So I think I've already got my first part, but let's start writing it down. So number 7, CR is parallel to DP, parallel to AB. This is given. And number 8 that I get is EC is equal to CP is equal to PA. This is from 6. So using equal intercept theorem. What do I get? Using equal intercept theorem, I get number 9, which is ER is equal to DR is equal to DF. Perfect. So now I already know that EF, I can write EF as ER plus DR plus DF. Let's replace ER and DR with DF. Perfect. So ER with DF, DR with DF, and DF is DF. Right. So this is number 11. Why? Since ER is equal to DR is equal to DF. This is from number 9. This is from number 9. So that gives us EF is equal to 3 times DF. This is what they wanted me to prove. So hence prove. So my first part of the question, which is EF is equal to 3 DF, is done. So what did I do first? First I proved that P is midpoint of AC, and then using the given information that C is equal to half AC, I proved that AP, PC and CE are equal. Now I use the equal intercept theorem to get ER, DR and DF equal. So now I've got EF is equal to 3 times DF. Now let's see if I can apply, how I can use it to get CR, or AB is equal to 4 times CR. I already know that AB is equal to 2 times DP, or DP is equal to half of AB. So now let's look at another triangle. Let's say I look at triangle BPE. Why am I looking at this triangle? Because I already know now that this and this are equal. We just proved that ER, DR and DF are equal, and we know CR is parallel to this, which means CR will be half of DP. So let's write this down. In triangle DPE, number 13, C is midpoint of EP, and number 14 is R is midpoint of ED. This is C is midpoint of EP. We will get it from 6. This is from 6. And R is midpoint of ED. We will get where we prove ER/DR is equal, which is from 9. Perfect. So using midpoint theorem, like I've said earlier, I'm using MPT. In an exam you will write the full form. So using MPT, what I get is CR is equal to half of DP. Perfect. So I have CR is equal to half of DP, and I have DP is equal to half of AB. So let's combine 4 and 15. So from 4 and 15, what do I get? I get CR is equal to half of DP, which is equal to half of AB, which means CR is equal to 1 by 4 AB, which means AB is equal to 4 times CR. This is what they wanted me to prove. So hence prove. Perfect. So interesting question, where we had to use the same concept couple of times and we got the results that we wanted. Wonderful. Let's look at the next question. The next question that we do is question number 4. Again, no diagram given, so we'll have to create our own diagram. Let's look at the question. Question 4 says, in triangle ABC, BP and CQ are the medians. So let's draw a rough diagram. So let's say this is triangle A, B and C. It says BP and CQ are the medians and they are produced. So BP is the median and it is produced. So this is BP is the median, which means it is dividing AC into 2 equal parts, and then CQ is also a median, which means it is dividing AB into 2 equal halves. Perfect. So this is CQ, and this is dividing it into 2 equal halves. Next, up to M and N such that BP is equal to PM. So BP is equal to PM. So BP and PM are equal. and CQ is equal to QN. So CQ is equal to QN. This is N. We need to prove that MAN are collinear, which means we need to prove that MAN is a straight line. This is what I need to prove, that MAN is a straight line, and then second part A is the midpoint of MN. So let's look at what we can do and see where will it help us. So let's look at some triangle which will help us identify either a midpoint or an equal intercept theorem. So let's see if I can identify a triangle. So I can notice that Q is a midpoint and P is also a midpoint. Okay, so let me join Q and P as well in any case. So it will help us understand the question better. So let's look at this triangle ANC. Perfect. So if I look at this triangle ANC, I have Q, which is the midpoint of NC, and P, which is the midpoint of AC. Let's see if it helps us doing something. So in triangle ANC, number one is Q is midpoint of CN, and 2, P is midpoint of AC. Both of this is given. Next, so using midpoint theorem, I can get two parts. So using midpoint theorem, what I'll get is number one, which is QP is equal to half of AN, and I will get QP is parallel to AN. Perfect. So I have got one triangle where I did something. Let's see if I can get another triangle where I have two midpoints. Again, this time let me look at this triangle which is AMP. Again, I have two midpoints which is Q and P. So let's see what will this give me. So in triangle AMP. So in triangle AMP, what do I get? This is number 5. Q is midpoint of AB, and number 6, P is midpoint of BM. Perfect. What I get is using midpoint theorem, number 7, which will be QP is equal to half of AM, and number 8, QP is parallel to AM. Done. So I have got two things using midpoint theorem. Let's see if this will help us prove anything. So let's see this part, number 7 and number 3. What does it give us? Let's see. So what I get is from 3 and 7, what I get is QP is equal to half of AN is equal to half of AM. This is my number 9. What I get then is AN is equal to AM. If I look at these two, half of AN is equal to half of AM, which means AN is equal to AM, which means AN and AM are equal. What does it tell me? That it tells me that A is the midpoint of. So since AN is equal to AM, therefore A is midpoint of MN. That's the second part that they wanted us to prove. I've already done the second part, but first part is remaining. Let's see how we can get it. What I have got from number 4 and number 8 is that QP is parallel to AN and QP is also parallel to AM, which means AN is parallel to AM, but they have a common point. So since AN is parallel to AM and they share a common point, which means two lines, if they are parallel, they cannot intersect, but in this case they have a common point, which means this is a straight line. Therefore, what basically means is that NAM is a straight line, because A is a part of NA and A is a part of AM as well. Since they share a common point, therefore MAN is a straight line. Perfect. I hope you got this point. If two lines are parallel, then they cannot have any common point. But in this case, these two lines are parallel, which means they are a part of the same line. Perfect. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.